Hello, everyone, and good evening. Today's lesson is from chapter 2, which in the version of the book I have starts on page 601. The chapter topic is on decimals and fractions, so let's get started. So the first lesson today is on decimal basics. Decimals are numbers that reflect amounts that are less than 1 by using place values. So you'll usually see a decimal point placed after a whole number, and everything that appears to the right of the decimal point indicates a portion of the whole number that you're dealing with. So once we're in the zone beyond the decimal point, we're no longer talking about the whole number, we're talking about a portion of it. And the further you move to the right of the decimal, the smaller the portion becomes. And you already use decimals in everyday situations that involve money. For example, you want to buy a milkshake and it costs $10.25. You already know by virtue of having dealt with financial transactions in the past that the digits to the right of the decimal point represent hundredths of a dollar, or cents, as the term is more commonly known. So a decimal point is used to separate a whole number from its decimal parts. And so when you're rounding decimals, follow the same rules that apply to rounding whole numbers. So when you're dealing with a number, adding zeros to the right of the last digit after the decimal point does not change the value of the number in question. So for example, if we revisit our milkshake example, if the price is $10 even, then you know that the zeros that appear after the decimal point, which would appear on your receipt, for example, means that the value of 10 essentially remains constant and does not change. So as discussed earlier, you'll usually see a decimal point placed after a whole number, and everything that appears to the right of the decimal point indicates a portion of the whole number that you're dealing with. So once we're in the zone beyond the decimal point, we're no longer talking about the whole number, we're talking about a portion of it. And the further you move to the right of the decimal, the smaller the portion becomes. So for example, in the number 2.375, that's shown below the number line, 3 represents 3/10, and the position of the 7 lets us know that we have 37 hundredths. So remember, the further that we move from the decimal point, the smaller the portion becomes. So the position of the 7 lets us know that we've gone from having 3/10 to having 37 hundredths. And if that's not clear, let me give a more relatable example. So it might help you to visualize pie that you have to share. So let's say you decide to cut your pie into 10 slices, and then 3 of your friends took a slice each. You would say that 3/10 of your pie is gone, right? But let's say that the next day you buy another pie because it was so delicious. Um, and let's say later that evening you have 100 dinner guests. And so you decide to cut your pie into 100 really thin slices so that each one of your guests can have a little piece of it, right? And let's say that only 37 of your friends, of your dinner guests, took a slice. Once the party actually ends, you'd say that 37 hundredths of your pie is gone. So if you visualize both pies, you can actually have a better understanding that in terms of proportioning, 3/10 is a lot bigger than 37/100. And the same concept applies to the position of the 5. Excuse me. The 5 is in the thousandths position, and the position of the 5 as part of that portion that we're looking at tells us that we have 375 thousandths. So let's say that you decide to buy another pie, and by some incredible feat, you're able to slice that pie 1,000 different ways. And then 375 people took a tiny slice of your pie, then you would say that 375 thousandths of your pie is gone. And so that's why this number that you see below the number line 2.375 is more formally read as 2 and 375 thousandths. Okay, normally you would hear it this kind of description, or you would hear it said like this when you're talking about rounding. So if on the test you're told to round to the thousandths position, and let's say the calculation showing in your calculator reads something like what I've illustrated here in the yellow rectangle, 2.37524, and so on and so forth, then you would write down the portion that's highlighted in pink, 2.375, to indicate that you have correctly rounded to the thousandths place. And so informally, or more commonly, like I said, we'd read this number as 2.375, and even the informal way of reading the number lets you know that each digit plays a unique role. So we don't read it as 2.375. We sound out each digit, each unique digit after the decimal point as 375 to reflect their unique and individual position on the number line. So here's a tip from the book. The mathematical reasoning portion of your test may show a 0 written before the decimal point, for example, 0.75, but just know that the 0 does not change the value of the number. So 0.75 is equal to 0.75, okay? Same difference, if you will, or no difference, I should say. On to rounding. When we round decimals in much the same way as we round whole numbers, we follow a similar process. So in this example, we're told that a calculator displays 3.62835, and we're asked to round to the hundredths place. So the first thing you want to do is look at the digit to the right of the hundredths place. So if the digit to the right of the hundredths place is 5 or greater, you would want to round up. But if the digit to the right of the hundredths place is 5 is less than 5, okay, not 5, less than 5, don't change the number. So once you've made your rounding choice based on the instructions that we've just covered, you can drop all the digits to the right of the place that you're rounding to, So in this example, since 8 is greater than 5, you would round up 3.62835 to simply 3.63. So the process involved with comparing decimals is similar to that of comparing whole numbers. So in this example, we're told that Matt ran a 400-meter race in 45.8 seconds. but Alonso ran the same race in 45.66 seconds, and we're asked to determine which runner has the fastest time. And so the first thing that you want to do here is to stack your numbers into a column. Excuse me. Stack your numbers into a column so that you can align each decimal point. And then the next thing you want to do is add a 0 to the end of 45.8 so that you'll now have the same number of digits after the decimal point for both running times. So then you'd compare the portions after the decimal point as though they were whole numbers, and you'd see that Alonso had the fastest time since 80 is greater than 66. So when you compare two or more numbers, it helps to compare one place value column at a time, and you want to work from left to right when you're doing so. In this particular example, we're asked to arrange the numbers 0.85, 1.8, 0.8, and 0.819 in order from greatest to least. So the first step is to stack your numbers into a column so that you can align your decimal points. Then you want to add zeros where necessary so that all your numbers have an equal number of decimal places. And now you can start comparing your digits, working from left to right. And since 1.8 has a whole number, it's safe to say that 1.8 is the greatest number. And since it's the only number of the set of numbers that we're looking at that has a whole number part, again, we determine that it's the greatest. And since the rest of the numbers have an 8 in the tenths column, you want to move to the hundredths column. And we can see that 0.85 is the next greatest number, followed by 0.819, with the least greatest being 0.8. So there's some practice exercises on decimal places starting on page 604 to 606. I would encourage you to work on those during your spare time. If you have any questions, feel free to contact me, or if you feel like getting additional tutoring, that's available to you also from Megan. So don't hesitate to ask or contact any one of us if you need additional help. So the second lesson in chapter 2 focuses on decimal operations, and there are a few key ideas that you want to keep in mind when you're working on decimal operations. So when you're adding or subtracting and you've stacked your numbers into a column to align the decimal places, always add or subtract digits with the same place value columns. And you want to make sure that you're placing the decimal point in your answer directly below, if you're adding, or above, let's say you're dividing, the decimal point of the numbers in the problem, okay? Adding decimal points is similar to adding numbers, right? The main thing, or adding, I should say adding decimal values, decimal numbers, is similar to adding whole numbers. The main thing to keep in mind, though, is that your place value columns need to be correctly aligned. And again, you align your place value columns by stacking your numbers into a column and then making sure that you've carefully aligned your decimal points. In this example, we're asked to add 0.37 plus 13.5 plus 2.638. So you want to start by stacking your numbers into a column, and then making sure to carefully align the decimal points in your stack. Then you want to add zeros as placeholders so that each number in your column has the same number of decimal places after the decimal point. Excuse me. So then you want to begin adding on the right. So in this case, the thousands column, we have 0 plus 0 plus 8, which equals 8, right? And then over to the hundreds column, we have 7 plus 0 plus 3, which equals 10. You write down your 0 and you regroup the 1. You carry the 1 over to the tenths column. And so 1 plus 3 plus 5 plus 6 equals 15. Write down the 5 and regroup the 1. And so now we're on the whole numbers side, right? But operationally, we're still doing the same thing, except that before we start adding, I put down our decimal point so we don't forget, and make sure it's aligned with the other numbers in the problem, okay? We have 1 plus 0 plus 3 plus 2 equals 6, and over. So now in the tens column, we simply have 1. And so now we can confidently say that 0.37 plus 13.5 plus 2.638 is equal to 16.508. All right, so with finding the difference, we follow essentially the same steps as we did in the previous example, except of course that we're subtracting this time around. So start by stacking your numbers into a column. Make sure that you align the decimal points. Add zeros as placeholders so that each of the numbers has the same number of decimal places after the decimal point. In this case, we need to add 2 placeholder zeros to 8.7, as you see has been done in this example. And so then you want to begin by finding the difference. So essentially you would subtract, regroup, borrow as needed. Same concept as with whole numbers. I'm going to begin your subtraction on the right. And in this case, in the thousands column, we have 2 minus 0, which is 2. Then over to the hundredths column, 1 minus 0 is 1. And then over to the tens column, 5 is less than 7. So we need to borrow a 1 from the 1 column. And since we're borrowing a 1 from 4, we need to put a line through 4 to remind us that we're borrowing a 1, and then we're going to regroup that 1 over to the tenths column, and now we have 15. Okay, 15 minus 7 is 8. Align your decimal point to match the decimal point of the numbers in the problem. And now we're on the whole numbers side. And again, operationally, we're doing the same thing. 3 is less than 8. So we need to borrow a 1 from the tens column. Since we only have 1, we put a line through it, write down 0. And now we have 13. 13 minus 8 is 5. And since we have 0 in the hundreds place, or 0 in the hundreds column, we've completed the task and we have our solution, 14.512 minus 8.7 equals 5.812. Here's another test tip from your book. Always make sure that your answer make sense, right? So for example, if you're asked to add 7.2 plus 1.4, your final answer shouldn't be something like 59.385, okay? So try to mentally round your numbers to the nearest whole number, then proceed with the required operation, and your result should be close to the approximation that you did in your head right before you started working on the problem. So for example, um, um, here you see that before you start calculating, you could mentally round 7.2 to 7, since 2 is less than 5. And you could mentally round 1.4 to 1, since 4 is less than 5. So you know that your answer, whatever answer you get once you start your calculations, should be less than 10, right? So if you're seeing an answer like, again, like 59.5, whatever, you know that you've made a mistake somewhere with your calculations. And that's what this tip is trying to, is saying, is essentially first try to round the numbers in your problem mentally, and then proceed with your calculations. And when you find your answer, do a comparison, and it should be in the same ballpark as the estimate that you came up with in your head. Sometimes when you see a problem where the largest numbers in the set of numbers you've been given to work with does not have any decimal places, in other words, you've been asked to subtract a decimal number from a whole number, like in this example, we're asked to subtract 3.604 from 9. Our first steps would remain the same. You would start by stacking your numbers into a column, making sure that you carefully align the decimal points. But in this particular case, you would add zeros as place numbers so that each number has the same number of decimal places after the decimal point, right? So in this case, we've added 3 zeros, and 9 now has the same number of decimal places after the decimal point as 3.604, okay? And then you would proceed as normal with your subtraction. In this case, since we have 0 in the thousandths, hundredths, and tenths column, we need to borrow from the tens column, right? So put a line through 9, write down 8 to help us remember that we've borrowed a 1. And then we need to regroup every step of the way until we get to the thousandths column. So think of it as paying a toll before you can pass over the bridge, right? Each base is literally saying, hey, before I let you cross over, you need to give me a 1, okay? So you begin by paying your toll. In the tenths column, you add a 1. Then you cross out 10 to borrow 1 again. And since we're borrowing a 1 from the tenths column, you write down 9. And we've borrowed a 1 from here. So we're going to add that 1 that we borrowed to the hundredths column. And now so we cross that out, write down 9, and we carry our 1 over to the thousandths column. And we now have 10. 10 minus 4 is 6. 9 minus 0 is 9. 9 is 6 is 3. And 8 minus 3 is 5. So we successfully subtracted 3.604 from whole number 9, and our answer is 5.396. So there's some practice tests starting on page 609 of your book. From page 609 to 612, the exercises are on adding and subtracting decimal places. So again, work on those and feel free to reach out to either Megan or myself if you need any additional help. 9 minus 6 is 3, and 8 minus 3 is 5. So we successfully subtracted 3.604 from a whole number 9, and our answer is 5.396. So there's some practice tests starting on page 609 of your book, from page 609 to 612. The exercises are on adding and subtracting decimal places. So again, work on those, and feel free to reach out to either Megan or myself if you need any additional help. Okay, so when it comes to multiplying and dividing decimal numbers, apply the rules that we learned from chapter 1 for multiplying whole numbers. So for multiplying and dividing decimal places, you don't need to align your decimal places as we did with addition and subtraction. Wait until you've completed your multiplication or your division, and then place your decimal point based on the number of decimal places that appear in the numbers for the problem. So for example, if you need to find the product of 2.6 and 0.45, write down the problem as though you were multiplying 26 and 45. In other words, ignore the decimal points and just carry out your multiplication as usual, okay? Excuse me. So when you have your answer, which in this case, 26 times 45 is 1170, or 1170. Well, how did we get to that answer, for example? First, let's go over that first. So the first steps, you're just gonna work, like I said earlier, the same way as you would with whole numbers, right? So 5 times 6 is 30. You write down your 0 and carry the 3 just above 2. 5 times 2 is 10, plus the 3 that we carried over is 13. So write down 13. Then we're going to put a placeholder under 0 here. 4 times 6 is 24. You write down 4, carry the 2. 4 times 2 is 8, plus the 2 that we carried over is 10. Okay, draw a line under that and proceed with your addition. 0 plus 0 is 0. 3 plus 4 is 7. 1 plus 0 is 1. And then obviously we just have 1. Now you want to count the number of decimal places in the numbers that were given in the problem. So we have for 0.45, we have 1, 2, and then 3, right? And so in the answer that you get over here, you want to move to the left by 3 decimal places and place your decimal point right here. And here you have your answer. 2.6 times 0.45 is 1.170. And don't forget to add the decimal point here because it's crucial to your answer. Because 1,170 is very different from 1.170, right? So you have to make sure that you insert your decimal point, and not only are you inserting your decimal point, make sure that you're placing it in the right place as well. Because if you put it here, for example, or here, your answer would also be wrong. So make sure that you've counted correctly the number of decimal places after the decimal point. Decimal points that show up in your problem, and then proceed accordingly with adding the decimal point in the correct place, oh my goodness, in your answer. So for a decimal division, you need to figure you need to figure out where the decimal point will be placed in your answer prior to dividing. So in this example, we need to divide 14.4 by 6. So your divisor, or the number that you're dividing by, is 6, and it's a whole number. So you would place the decimal point in your answer directly above the decimal point in the dividend, or the number that you're dividing, which in this case is 14.4. You want to place your decimal point directly above the dividend. So start by placing your decimal point here, and then proceed with the rules for division. So 6 doesn't go into 1, so we write nothing here and we move on to the next place. 6 goes into 14 twice. 6 times 2 is 12, so we write down 12. You draw your line and you subtract 14 from 12. You get 2, but we're not done, are we? We need to bring down the 4. 6 goes into 24 4 times. 6 times 4 is 24. 24 minus 24 is 0. Now we're done. We have our answer. 6 into 14.4 is 2.4. So if your divisor happens to have a decimal point, you must move the decimal point in both the divisor and the dividend before you can divide. So in this case, we need to divide 0.35 by 4.9. So your divisor, 0.35, has 2 decimal places, and that means that, hi, Jaleesa.
Hi, I'm here.
I'm trying to add myself back to the screen. Is your video on by any chance?
Yes, the video's on.
Do you mind turning it off?
Oh no, yeah, I got it off. I turned off.
Um, can you see me?
Yeah, I can see.
Oh, okay. I'm not showing in the thumbnail. Okay, here we go. All right. So let me start over with this portion of the lesson. So if you're let's see, let's go back. Okay, so if your divisor happens to have a decimal point, you want to move the decimal point in both the divisor and the dividend before you start to divide. So in this case, we're being asked to divide 0.35 by 4.90. So your divisor, 0.35, has 2 decimal places. So you need to move the decimal point in your dividend by exactly 2 decimal places. So start by moving the decimal point in 0.35 by 2 over to the right. So 1, 2, because we want to make it a whole number. So now we have 35. And then you would also move the decimal point in the dividend by exactly 2 decimal places. Okay. Then you can start your division as normal. Now, oh, by the way, you also want to make sure that before you start your division, you want to put your decimal point right here in your answer, so that you know where your decimal point is supposed to be in your answer, right? Now we can proceed with division as normal. So 35 does not go into 4, so we leave nothing here, we write nothing here. Move on to the next place. 35 goes into 49 1 time. 35 times 1 is 35. 49 minus 35 is 14. Bring down the 0. 35 goes into 140 4 times. 35 times 4 is 140. 140 minus 140 is 0. And we're done with our division. But we know there's a decimal point here. So in your answer, you can either just write 14 or you can write 14.0, just to acknowledge that there's one decimal place after the decimal point, and in that tenths position is 0. But as I mentioned earlier during the lesson, 14.0 and 14, essentially the same number. The 0 after the 14 doesn't make a difference to the value of the number. Practice tests start on page 600. Either Megan know, and we'll be happy to help. Okay, and so on to lesson 3. And this portion of the chapter covers fraction basics. So the bottom part of a fraction tells you how many parts the object has. Or, yeah, let's leave it that way. And the top part of the fraction tells you how many parts of the group or how many parts of the object are present, right? Or how many parts you're working with. So the bottom part tells you, is an indication of the complete part. How many complete parts are you working with? And the top part is an indication of a portion of those complete parts. And I think that will make more sense as we go along. So when you see a top-heavy fraction, that means that the top of the fraction is greater or is bigger than the bottom of the bottom part of the fraction. And it simply means that the fraction is greater than 1. So if you saw a fraction like 5/3, that's a top-heavy fraction because 5 is greater than 3. And what that fraction is telling you is that that fractional component, or that fraction that you're looking at, is greater than 1. So a fraction uses two numbers to represent a whole number. The bottom part of the fraction is called the denominator, and it tells you how many equal parts are in the whole, or in the whole group. The top of a fraction is called the numerator, and it tells you how many parts that you're working with. So in this illustration, we see a rectangle with 4 equal parts, right? And of the 4 equal parts, we see that 3 of them are shaded in gray, right? So another way of saying this is that 3 out of 4 parts in this rectangle are shaded. So let me move this a little bit so we can see. Okay. So when the numerator is smaller than the denominator, you have a proper fraction. I mentioned earlier that if you see a fraction with a numerator, the top part, that's bigger than the denominator, you have an improper fraction. So when the numerator is smaller than the denominator, you have a proper fraction. And that always represents a quantity less than 1, okay? An improper fraction, as mentioned earlier, is top-heavy, and that always represents a quantity that's greater than 1. So in the rectangle you see here, we have 6 equal parts, and all 6 parts are shaded in gray. Therefore, we know that 6/6 parts of the figure, or the whole thing, is shaded in gray, and 6 divided by 6 is 1, right? So 1 meaning the whole thing is shaded in gray. So another way of thinking about this is how many parts of this rectangle are shaded in gray? Well, the whole thing, right? And that's what this 1 represents. Or you can also write it as 6 over 6. For the pair of circles that are shown, each circle is divided into 2 equal parts, right? And so we can say that a total of 3 parts are shaded, or 3 over 2. And the 2 here represents each individual circle, and then the 3 represents the number of shaded parts. And so 3, if someone was to ask you, well, how many parts of these 2 circles are shaded, your answer would be 3, 1, 2, 3 over 2 of the 2 circles. So this is an improper fraction. And if you wanted to write it as a mixed fraction, or that more, well, I shouldn't say more closely, because it's essentially the same thing, and you'll see what I mean in just a minute. So you would divide, you would ask yourself, how many times does 2 go into 3? 1. And what do you have left over? 1. And 2 is your denominator, right, which we started with. And so another way of looking at this fraction here is to look at this picture. We have one whole circle that's shaded in, and then we have one circle with only half of it shaded. So we have 1 and 1/2. Okay. Do you have any questions, Jaleesa?
No, I'm good. I'm following along.
Okay, cool. So if this is a good tip that I saw that's in the book. If you're having trouble visualizing the fractions in your problem, just draw a quick sketch of the information presented, similar to what we've just seen in the last 2 examples with the rectangle and the 2 circles. Okay, so here you can change an improper fraction to a whole number or to a mixed number. Here we're being asked to change 16 over 5, excuse me, to a mixed number. So you pretty much just want to start by dividing 5, your denominator, into your numerator. So how many times does 5 go into 16? 3, right? Because 3 times 5 is 15. So you write down your 3, and what's 16 minus 15? 1, and that's your remainder. So our answer here is 3, remainder 1. And you can rewrite that as 3 and 1/5, right? Because we have we said that the number of parts, the complete number of parts that we have is 5 different parts, and we're being asked how many times can 5 go into 16. And the number is 3. 3 times 5 is 15, and we'll have 1 left over of the 5 parts. Okay. Here we're being asked to change 7 2/3 to an improper fraction. And again, remember, an improper fraction is a top-heavy fraction where the numerator is greater than the denominator, or another way of saying that is that the top part is greater than the bottom. So you would start by multiplying the whole number, which is 7, by 3, okay? And then you would add the numerator. So 3 times 7 is 21, plus 2 is 23. And so your improper fraction, the correct answer would be 23 over 3. Okay, and just always keep in mind that the denominator is king, right? So you're reflecting the whole thing, like we saw earlier with 6 over 6, for example, or if you're reflecting part of it, like we saw in this example, where we have a remainder of 1, the denominator reflects the whole thing, which is 5 parts, right? So your denominator doesn't change here either. We have 3 times 7, which is 21, plus 2 is 23 over 3. So to perform operations with fractions, you need to be able to write equal fractions in higher or lower terms. So the terms are the numerator and the denominator, and then the fraction is what you would reduce to the lowest terms when the two terms don't have a common factor, okay? And I'll explain that a little bit more. So to raise a fraction, you would multiply both the top and the bottom by the same number. So for example, if you wanted to raise 3 over 4, the least common multiple is 3. And so you would multiply 3 by 3 and 4 by 3, and you would get 9/12. And I think this will become clearer as we move on with other examples. So to reduce a fraction, you want to divide both terms by the same number. So 10 over 15, we know that the least common multiple between 10 and 15 is 5. So we can divide 10 by 5, and that gives us 2. And we can divide 15 by 5, and that gives us 3. And, this is where, if you remember in the first lesson, one of the test tips was asking you to memorize your multiplications table. This is where that becomes important because it makes it easier for you to quickly recognize least common multiples that you'll need to apply when you're dividing fractions, for example. So practice tests start on page 626 to 630. Again, let me know if you need any help. Megan is available to help with tutoring as well. So you can add or subtract fractions, but they need to have the same denominator. So if the denominators are not the same, again, the denominator is the number on the bottom. If the denominators are not the same, you need to find a common denominator between both fractions, and then you need to raise one or both of the fractions, and then continue with the operation as normal. And you always want to reduce your answer to the lowest terms. So that's kind of an example. If an answer if a question tells you, make sure that you reduce your answer to the lowest terms, you understand that if you came up with something like 10 over 15, that's not the lowest term because it can still be divided by, this fraction can still be divided by 5. This is its lowest term, okay? Yeah, that's essentially it for that. All right, so you can add or subtract like fractions. And like fractions will always have a common denominator. In other words, their denominators are the same, and that's why they're called like fractions. So in this example, we see like fractions, right? We're being told to add 3/10 plus 5/10, right? And so since the denominator is the same, you can start by writing down your denominator, which is 10, and then you simply just add 3 and 5, and you have 8. And so your answer is 8/10, but we're not done because this can be reduced further. And the least common multiple between 8 and 10, least common multiple just means the smallest number that can be divided into a whole number without leaving a remainder, right? So for example, if we try to divide 3 into 8, we would get 2, but then we would also get 2 left over because 3 times 2 is 6, and 8 minus 6 is 2. So if you try to divide 3 into 8, you can do it, but then you would have 2 left over. But if we picked the number 2 and divided that into 8, we get 4 with nothing left over, right? So if that's the same as thinking of it as like you have $8 and you want to give it to, and you have to give $2 to a group of people. How many people would get $2? Well, the answer is 4, right? But if you had the same $8 and you wanted to give $3 away to a group of people, how many people could get $3? The answer is 2. 2 people would get $3 each. So you would have given away $6, but then you would have $2 left over, right? And our goal was to give away $3. So conceptually, when you're thinking about it, the least common multiple is a number that you can divide into your whole number, and you can do so and get equal parts for both your numerator and your denominator. In this case, that number is 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. And now we have our lowest term, which is 4/5. And so we can confidently write our answer. 3/10 plus 5/10 is 4/5. So here's an example of subtracting like fractions. Okay. What you want to do here is just switch over so that you have the fraction with the larger denomination, or the larger numerator on your left-hand side, right? And then you would just proceed as normal. Since both the denominators are the same, you write down your denominator, which is 9, and then 7 minus 2 is 5, okay? So this tip is essentially just letting you know that you should make sure to always reduce your answer to the lowest terms, because sometimes, especially with decimal places, you might arrive at an answer and then look over at the answer choices and your answer is not there. Even though you have the right answer, you have a partial answer because you haven't reduced your answer to its lowest terms. And so this is just a reminder to do that. All right, so here we're being asked to add 2 unlike fractions, right? 5/6, which is top heavy, right? 5 is, I'm sorry, it's not top heavy. 5/6 plus 1/4. The denominators are not the same, is what I meant to say. Okay, so the first thing you want to do is find a common denominator. So you want to think of the multiples of both of your denominators that's the lowest. between them. Like, so for example, multiples of 6, 12, and 18, and multiples of 4, 4, 8, and 12. Well, between them both, they have, they share 12 as a common multiple, and it's also the lowest, right? Because we can keep going with this, and we would find on the 24, they also share 24, because 6 times 4 is 24, and 4 times 6 is 24, but it's not the lowest multiple, is it? 12 is, right? So you always want to pick the lowest multiple. And in this case, it's 12. So then you would raise each fraction to higher terms with a denominator of 12, right? So 6 times 2 is 12. So that means we need to multiply 5 by 2, right? Whatever you do to the denominator, you always want to do that to the numerator. So since we had to multiply 6 by 2 to get 12, because again, we have to start by finding a common, the lowest common multiple. So we had to multiply 6 by 2 to get 12. We're going to have to multiply 5 by 2, and that answer is 10. And then we have to multiply 4 by 3 to get 12. So we're going to have to multiply 1 by 3 to get, and that gives us 3, okay? And so now we have, we've put our fractions into like terms, and it's now easy for us to add, right? So 10 over 12 plus 3 over 12 is 13 over 12. And this is not the lowest, this is not its lowest form, right? So we need to divide 12 into 13, and that gives us 1, okay? And then we have 1 left over, okay? And that's where this 1 comes from, 1/12, okay? I think if it helps, you can draw like that. This is the equivalent of drawing a rectangle with 12 equal parts and only 10 are grayed out. And then you draw another rectangle with 12 equal parts, only 3 are grayed out. So how many grayed out rectangles, or how many grayed out portions of the rectangle do you have? 13. And another way of writing that is that you have one whole rectangle that's grayed out, because here 10, 12 is indicative of a whole, right? And 10 plus 3 is 13, and in that 13 is 12, right? So we have one whole part, or one whole rectangle that's grayed out, and then we'd have 1 left over, because 13 minus 12 is 1. And so 1 of the 12 parts, that makes sense. Jaleesa?
Oh, yeah, it makes sense.
Okay. All right, so here we're being asked to subtract 4/16 from 1 3/8. So between 16 and 8, you already know that 8 times 2 is 16, right? So to make sure that your denominators both have this have the same number, all you would need to do here is raise 8 by 2, and then because you've raised 8 by 2, you would also need to raise 3 by 2, okay? So you would take 3/8 and multiply both the numerator and the denominator by 2, and that gives you 6/16. And then you can write your, you can rewrite your fractions in terms of the new denominator that you have for 1 3/8, okay? Now, you can't just, how can I put it this way? You need to make sure that the number on the left-hand side is greater than the number, the numerator, I should say, on the left-hand side is greater than the numerator on the right-hand side, right? We can't subtract 1 from 3. So what we need to do is break down this fraction a little bit more. And this is where it will help you to visualize those two circles that we saw earlier, right? So this 4 and 1/16 is just telling us that we have 4 circles, okay? And all 4 of those circles are divided into 16 parts, and all 16 parts are grayed out, right? So this 4 simply means that we've got 4 circles, because remember, this 4 is part of a fraction. It's a mixed fraction. And that's really what this, so an English teacher would tell you straight away, we've got 4 circles with 16 parts, and then there's 1 circle that only has 1 part grayed out. But a mathematician will tell you this way. They would write it in numerical form. So this fraction is simply telling you that you've got 4 circles with 16 parts that are grayed out, and then you've got 1 circle with only 1 part grayed out, okay? So another way to rewrite 4 and 1/16 is 3 and 16 over 16 plus 1 and 1/16. And essentially this, I'm trying to think of the best way to explain this. So again, like I was saying earlier, this 4 is indicating that we've got 16 over 16 4 different times, okay? Or we've got 4 circles with 16 over 16 pieces grayed out, right? But now we need to borrow one of those, we need to borrow from one of those grayed out circles. So when we remove a circle from 4 circles, we have 3 circles left over, right? So that's what this 3 is indicating. And then this 16 over 16 is indicating that we've removed one of those circles from 4, okay? So now we have 3, 16 over 16, but don't remember, we also had, don't forget that we also had 1 circle that only had 1 portion of it grayed out, okay? So another way of writing 4 and 1/16 is 3 and 16/16 plus 1/16, okay? Or you can think of it as 16 over 16 plus 16 over 16, 2, plus 16 over 16, 3, plus 16 over 16, 4, plus 1/16, okay? So this notation here, 3 and 16 over 16, is just a different way of writing 4. But it's just a mathematical way of writing this 4, because we're dealing with fractions. Okay, I'm not sure if that's clear. If it isn't, indicate.
I understood what you were saying because you just got to borrow basically 16 more pieces from the 4 and add it to the 1.
Exactly.
No, I get it.
Yeah, brilliant. So now we can continue with our subtraction, because now we have 17. Okay. So we can subtract 17 from 6. Remember, it's 6, not 3, because we've raised 3 by 2 and 8 by 2, because we were trying to, we started off by trying to match the denominators, right? So now we can subtract 17 from 6 to get 11. We subtract 3 from 1 to get 2, and the denominator stays the same. Okay. And I think, it helps to visualize it. It helps to visualize this if you have to, but I think you get the point. All right, so there are more examples on 633. I know the page numbers don't match, but essentially, I just want you guys to do all the practice problems after each lesson. All right, so with multiplication, it's not necessary to find a common denominator to multiply and divide. Well, because you would, okay, let me just put it that way, to multiply, but you simply need to multiply the numerators and the denominators, and then reduce the answers if necessary. And I think that's going to be clear with the examples coming up. So in this example, you're being asked, what is the product of 7/8 and 1/2? And so you want to start off by multiplying the numerators together and then the denominators, and then putting the answers in the lowest term. So 7 times 1 is 7, 8 times 2 is 16. And this, they don't have a common multiple, so that's your lowest term. In this example, you're being asked, what is 1/3 of 3 3/4? So the first thing you want to do, so in this example, let me go back. Here it is. In this example, we worked with the fractions. We didn't change the fractions to improper fractions because we were given 2 mixed fractions, right? The thing about fractions is you're always looking for similarities. So here on the left-hand side, we have a mixed fraction. On the right-hand side, and a mixed fraction just means you have a whole number and a fraction, right? So on the left-hand side, we have a whole number and a fraction, or a mixed fraction. On the right-hand side, we have the same thing, so we can work with this. In this example, we have a proper fraction. The numerator is smaller than the denominator. We have a proper fraction. And then on this side, we have a mixed fraction. So what we need to do is change the mixed fraction into an improper fraction, top-heavy fraction, so that we can work with it. So you would start by changing 3 3/4 to an improper fraction, and you do that by simply multiplying the denominator by the whole number, so 4 times 3, and then adding the numerator. 4 times 3 is 12, plus 3 is 15, and now we have our improper or top-heavy fraction, and we can multiply 1/3 by 15/4. And you would simply just multiply across the numerator and the denominator. So 15 times 1 is 15, 4 times 3 is 12, but we're not done, right? Because this fraction is top heavy. So you would divide 12 into 15, and that gives you 1 with 3 left over. And you would just write your remainder in terms of a fraction. That just means that of the 12 portions, we have 3 left over. So we have 1, can think of it as a circle with 12 equal parts grayed out, and then 3 left over, 3 parts out of 12, okay? And we're still not done because between 3 and 12, we know that 3 can divide into 12. So 3 into 3 is 1, and 3 into 4, excuse me, 3 into 12 is 4. And so our fraction, or our answer in its lowest terms, is 1 1/4. Okay. So you can use a shortcut called canceling to reduce the fractions as you're working through your problems. And to cancel, you simply just divide both the numerator and denominator by the same number. The numerator and the denominator can be in different fractions, okay? And you'll see what I mean by that in a minute. So here we're being asked to multiply 1 1/2 by 1 1/5. So here we're going to change this mixed fraction, since it's a lot easier with multiplication to change. Okay, let me go back to the example because I brought this up earlier and I don't want you to. Okay, so here we were subtracting, right? And so it's easy because if you think of it in terms of, if you go back to your circles, right, you've got to figure out how to subtract your the fractional portion, right? So with this, we didn't need to change this mixed fraction to an improper fraction, right? With multiplication, it's different. With multiplication, you have to change the mixed fraction to an improper fraction because it just makes it easier for you to work with, okay? So just follow the steps that we've already discussed in terms of changing the mixed fraction into an improper fraction. So 2 times 1 is 2, plus 1 is 3, and that's your first fraction. And then 5 times 1 is 5, plus 1 is 6, and that's your second fraction, right? And so now you want to set up the multiplication problem. And since both 6 and 2 are evenly divisible by 2, you want to divide both by 2. Okay, so divide 2 here. 2 goes into 2 once. 2 goes into 6 3 times. And then you just multiply across. 3 times 3 is 9. And 1 times 5 is 5. Okay, and again, top heavy. So you want to divide 5 into 9 one time. You're left with 4. 9 minus 5 is 4. So you're left with 4 parts of 5. 4 parts of 5, okay? And the slash marks, again, just are an indication that we're dividing. I'll go over that again just in case, okay? So you're going to start by changing the mixed fractions into an improper or top heavy fraction. And the reason you want to do that is because it's just easier to multiply across, because right now we can't just multiply across. We want to simplify it, and the easiest way to go about that is to change both into improper fractions, right? So 2 by 1 is 2, plus 1 is 3. We have 3 over 2. 5 times 1 is 5, plus 1 is 6. We have 6 over 5. Okay, so you write out your new fractions as 3 over 2 times 6 over 5. And then before you multiply across, you want to make sure that if parts of your fraction are evenly divisible, you do that first, right? So 2 can go into 6. 3 can't go into 5, so we just leave that alone. If this was maybe 7 here, then we would just go ahead and multiply across because into the numerator in our fraction on the right-hand side, right? So we just leave it as is. And you can only you can only divide across, right? Not because if you were to divide from bottom to top here, you would get back to the same story you had here, right? So we're not going backwards, we're going forward. So we've already completed the step that we needed to turn this into a top-heavy fraction. And now we need to ask ourselves, can we simplify this further before we start multiplying? Okay. And the answer is yes, because 2 goes into 6. So 2 goes into 2 once, that's what's shown here. 2 goes into 6 3 times, and then you multiply across to get your answer, 9/5. But you're not done because this is still top heavy. So you want to write it in its lowest form. 5 goes into 9 once, and you have 4 left over. And now you have your answer. 1 1/2 times 1 1/5 is 1 4/5. Okay. And the other reason that you can't just multiply across is with multiply across mixed fractions is that you would get the wrong answer. So if you decided, no, I don't want to change this to an improper fraction, I want to multiply across, okay, fine, you can do that. 1 times 1 is 1, okay. But 1 times 1 in your numerator is 1. And you can already see that that's wrong. 2 times 5 is 10, okay? So you would get 1 1/10, and that's not the right answer. So with multiplication, you always want to make sure that if you're given a mixed fraction, you want to change it to an improper fraction first, and then carry out your multiplication, because it's so easy to just multiply across, right? But when you're multiplying across, you don't want to see anything interrupting your multiplication, okay? So you want to make sure that you've turned your mixed fraction into improper fractions first. And then you go ahead and multiply across, okay? So with dividing, you need 2 additional steps. Before you can divide, you need to invert the divisor or the fraction that you're dividing by. And to invert the fraction, you simply need to switch the numerator and the denominator, and then finally change the division to multiplication and then multiply. And that'll be clear with the example that follows. Okay, so in this example, Jim has an 8-pound bag of nuts, and he wants to fill smaller half-pound bags using the nuts that he has, using the 8-pound bag. And the question is asking you, how many small bags can Jim make from his 8-pound bag? So you want to start by dividing. You basically need to divide 8 by 1/2. So you set up your division problem, and you always want to write if you have a whole number like we do here, or if you have a mixed number, like 1 1/5, for example, you always you either write the whole number in terms of a fraction. So to do that, we would just put a 1 under 8, because 8 over 1 is the same as 8, right? Or you would convert your mixed fraction into an improper fraction, and then you would proceed, right? So the same multiplication and division, as you may already know, you always want to, they almost mimic each other in terms of operational procedures. So if you have a mixed number, you want to change it to an improper fraction. If you have a whole number, you want to change it to a fraction by simply adding 1 underneath. Okay, so here we rewrite 8 divided by 1/2 as 8/1 divided by 1/2. Okay. And now you can go ahead and multiply across. 8 times 2 is 16. Once you've written your whole number as a fraction, okay, you need to invert the other side of the fraction, the right-hand side of the fraction. So that just simply means flip this 1/2 on its head. So that becomes 2/1, okay? And then you can multiply across. And I think that it would help if you write down the rules. So write down the rules for addition, write down the rules for subtraction, for multiplication, for division. And then when you're working on your problems, just follow those rules. And the more you follow the rules, the more it'll become sort of natural to you as you're working on the problems. And it'll be easier for you to remember, because know that when we were multiplying, for example, we didn't need to invert the right-hand side, but with division, you need to do so. So we've written our whole number as a fraction, and now we need to invert the right-hand side. So turn the 2 on its head, and you now have 2/1, okay? Hello? Oh, you're back? Okay.
I'm sorry, my connection went out.
Oh, it's okay. So, yeah, just make sure that there are a lot of rules here and there that you need to keep track of. And I was saying, I'm not sure if you heard me before, but it'll be easier for you to write down the rules for each operation. So what are the rules? What are the rules for addition when it comes to fractions? What are the rules for subtraction? What are the rules for division? What are the rules for multiplication? And then as you work on them, just follow the rules. And the more you do that, the easier it'll become for you, or you'll get used to the rules so that you don't get mixed up in terms of what you need to do. So we've written our whole number as a fraction. We're going to flip the right-hand side, and now we can multiply across. 8 times 2 is 16. 1 times 1 is 1. And so Jim, if he has an 8-pound bag of nuts and he has half-pound bags that he wants to fill them up with, he can fill a total of 16 half-pound bags with 1 8-pound bag. Okay. So when you multiply by a fraction that's less than 1, the answer you get will always be smaller than the number you started with, because you're finding a part of something. And let me just go back to one of the slides as an example. Okay, so here's an example, right? We multiplied 2.6 by 0.45. And our answer is less than 2.6 because we're multiplying a small part, this portion of a number that's less than 1, essentially, because 0.45, think of it as 45 cents, right? That's less than $1, right? You're multiplying a small portion into a much larger number, but you shouldn't get a number that's larger than this. You shouldn't get 50, for example, okay? And that's all that example is trying to tell you, or that statement, I should say, is trying to tell you. I just needed a visual way of illustrating that, but I think the point is clear. And then the other statement is telling you, it's on page 53. When you divide by a fraction that's less than 1, the number is always greater. And let me show you. Okay, so here we're dividing by 0.35, which is less than 1, and our answer was greater, our answer was 14. And that makes sense because if you, let's say you had, you can think of this as maybe $4.90, and you need to split, you need to give several people 35 cents, right? How many people can you give 35 cents if you have 400, why did I say $4.90, okay? And immediately, yeah, you can give that to a couple of people. You don't know the exact number yet, but your answer wouldn't be 1, for example, right? Because you know that 35 cents would go into $4.90 a couple times, right? And your answer is 14, right? And that's essentially what the other statement is trying to make, is that if you're dividing by a number that's less than 1, or a decimal that's less than 1, you shouldn't get your answer shouldn't be smaller than the decimal. Your answer should be greater. So if you see 14 as your answer, don't freak out. It makes sense because that's the expectation. That's essentially what this statement is. When you're multiplying by a fraction that's less than 1, the answer should be smaller, and that should make sense to you because you're essentially you started with, you're finding a part of something, right? So it should be smaller. And when you're dividing by a fraction that's less than 1, the answer should be greater than. If you think of it, I think in terms of dollars and cents, it might make it a little bit clearer to understand. So that's pretty much it for today's lesson.